Good morning, everyone. Today we're going to be talking about geometry in the coordinate plane, or geometry on what we would have thought as an Algebra 1 graph, right, where we got our four quadrants. All right. Basically, what we're going to be looking off of is we're going to look at the same basic traits we looked at yesterday for is it a parallelogram, rectangle, rhombus, square. All right, and we're going to be looking at different types of shapes and seeing which one of those we can classify it as, just given where the points of all the vertices are. All right, to get started with this, we're going to skip down and look at those two examples right there. All right, the first one, it tells me that we have 3 points, A, B, and C, and what points they are. All right, it also tells me that my shape needs to be a rectangle. All right, and it wants me to find where would D be for it to be a rectangle. So if we go look over here, most of us are probably going to guess somewhere in this area up there. All right, and you would be right. D's going to go specifically right here at that point. All right, why? Well, in order for this to be a rectangle, if I combine it, all right, a rectangle has to have 4 right angles. If we look at that, that's true. All right, it also has to have opposite sides that are parallel because it's a parallelogram too. All right, each rectangle will be a parallelogram, so you have to make sure A to B on this side is parallel with C to D on that side, and A to D up here is parallel to B to C down here. Since that's true, we know that's where D has to be for the shape to be a rectangle, and that is point 4, comma 4. All right, that's how we do that one. All right, next one. Don't know why it says letter C, but it does. So letter C. All right, this one's just a parallelogram is what we're looking for. So the big thing you have to make sure is that when we plot D, both sides are parallel. Well, we know that means since BC is going this way, going up, we know it has to go up at that kind of slant, so we know it has to be somewhere over there, would be a general good first idea. All right, but how can we tell if it's truly parallel? Well, earlier in the year, we talked about parallel lines have the same slope. So if we have parallel lines, that means we have equal slopes. All right, so in order to make this parallel, I gotta find the slope over here. Well, from B to C, it goes up 1, 2, over 1, 2. That's 2 over 2, which is the same as 1 over 1. All right, so when we go from A, I'm going to go up 2, to the right 2, put a little dot there. All right, let's double check for the other one. From A to B, it's up 1, to the right 4. If I go from that point that I just plotted, I go up 1, to the right 1, 2, 3, 4. All right, so what that means is that both sides then are now going to be parallel because this was 2 over 2 or 1 over 1, which is what we want. So this side is parallel to that side. And from here to here, it's up 1 over 4, which means this side is parallel to that side. All right, so I know that that's my correct point because those opposite sides are parallel. And that's all it has to be for a parallelogram. All right, so D is at 2, 2. All right, so parallelogram, you have to make sure your opposite sides are parallel. All right, technically I had to do that for the rectangle up here too, but since they're vertical and horizontal, I already knew that. All right, for a rectangle, I also had to have right angles. All right, that's when it forms right angles, that's what we're looking at as perpendicular lines, which remember those have opposite reciprocal slopes. meaning that one's positive, one's negative, and their fractions are what we call inverses or reciprocals, meaning that the fraction is flipped. So the denominator is now the numerator, and the numerator is now the denominator. All right, there's a couple for you here to try on A and B. I'm going to skip ahead. All right, now the other thing we can do when we have these is they can give us all 4 points. So like here they give us quadrilateral A, B, C. All right, and tell us A, B, C, and D. They tell us what all 4 of the vertices are, not vertexes, vertices. All right, and they want us to show, is it a rectangle? All right, is it a rhombus? Is it a square? Is it a parallelogram? All right. Now, they list a couple methods for you to be able to do this. Those aren't the only 2 ways. All right. My recommendation and what I use is method 1. All right. First thing I do is I check are opposite sides parallel. All right. If they are, that means it's a parallelogram. And I'm going to abbreviate or rewrite that. All right. The next thing I'm going to check are the adjacent sides perpendicular. All right. If they are perpendicular, that means it's a rectangle or square. If not, it's a rhombus, or it could be a rhombus. Actually, I want to leave that one off. All right. If they're not perpendicular, it could either be a rhombus or it could be a parallelogram. All right. The last thing we need to look at are all sides equal. I want to cross off that knot there. If they're equal, it's either a rhombus or square. All right. So on each one of these, we're going to have to check those 3 things. First, are the opposite sides parallel? All right. 2, are the adjacent sides perpendicular? 3, are the sides equal? All right. We have to check all 3 of those on these. All right. So if you notice, all right, I think it's very helpful to draw a picture. So I'm actually going to take this down and I'm going to do it on a separate page, and I'm actually going to draw a picture for it. Oops. All right, so I'm going to do that. Copy. All right, and the first thing I always do is I draw a graph and I plot it. And notice all those are positive, so I'm not really going to draw the negative side of my graph. I need to get 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. 1, 2, 3, 4, 5. All right, A is 2, negative 5, so A is way down here. B is 8. I think I only went 7. 8. Negative 3, so B is down here. C is 7, 0, so right here. And D is 1, negative 2, so right there. All right, so if we look at that, it looks like a rectangle. Maybe, but we don't know for sure because, well, those of you that have me in class, you know I'm not an artist. All right, we have no idea if I drew that accurately. All right, so the first thing we want to check is slopes. Or we want to see, are the opposite sides parallel? So from A to B, well, I've gone up 1, 2. over 1, 2, 1, 2, 3, 4, 5, 6. So that's up 2 over 6 or up 1 over 3. If I check D, up 1, 2, 1, 2, 3, 4, 5, 6. All right, so those sides are parallel. I check the other sides a little bit closer. From C to B, it's down 1, 2 over 1. So that would be 1, 2, 3. Sorry, I can't count. So that's negative 3 over 1. And I go from D to A. Or I could go from A to D. I'd go up 1, 2, 3. But I'd be going left 1. All right. Since it doesn't matter where I put the negative, I could take the negative from down there, from the negative 1, and put it up with a 3. Notice now, those sides are parallel. So opposite sides are parallel. Step 1. All right. Now, are adjacent sides perpendicular? All right. So basically, is 1 over 3 perpendicular to negative 3 over 1? All right. They're opposites. One's positive, one's negative. And the fractions are reciprocals because 3's on the bottom of 1, 3's on top of the other. One's on the numerator of 1, one's the denominator of the other. So, yes, opposite sides are perpendicular. All right. Last thing to do here. All right. Are all sides equal? Well, to do this, we have to use the distance formula or Pythagorean theorem. All right. Distance formula. All right. Is just distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, and we just plug it in there and we see what we get. All right. Now, I'll need to check all four sides. All right, because since it's a parallelogram and I showed the opposite sides were parallel, I already know CB and AD are the same, and I already know AB and CD are the same. So really, I just need to check one of the sides going left and right and one of the sides going more up and down. All right, so I'm going to choose what they did up here is they did AB and BC, so I'm going to do that. A to B would be, all right, I know I'm trying to make room here, the square root of eight minus 2 squared and plus negative 3, not comma, minus negative 5 squared. All right, that will become an add there. Negative 3 plus 5 is 2, squared is 4, plus 8 minus 2 is 6, squared is 36, which will be the square root of 40, which, for those of you that want to be overachievers and reduce that, it's the same thing as square root of 4 times square root of 10, so 2 square root 10. In all honesty, though, I can leave it right here and look at it from right there. All right, notice that's what they did up here, is they just left it as the square root of 40. So you don't have to simplify that one. All right, now let's try BC. All right, we're going to do the same thing. All right, I think C was 7, 0. So we're going to take square root of 8 minus 7 squared plus negative 3 minus 0 squared. This part's 9. That part's 1. gives me just the square root of 10, right? Notice the square root of 10 is not the same as the square root of 40, so all sides are not equal. All right, that's why the most specific name for this is a rectangle. All right, because the sides aren't all the same, so it's not a square or a rhombus. The adjacent sides are perpendicular, so that means we have 4 right angles, which makes it a rectangle. All right, guys, at this point, I'm just going to work through this last example down here. All right, if you want to jump off because you know what you're doing, go for it. If you'd like to stay and watch, that is fine as well. All right, so this one they want to find the most specific name, so we're not sure what this one is. All right, but they give us all the points. So once again, I want to make a quick sketch of that. I'm going to erase this extra part over here so I have more room. All right, I'm going to make a quick sketch of that. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, and 4. All right, C is 0, 4, so C is up here. D, negative 4, 2. D is out here. B, 1, 2. B is right here. D is, not D, A, negative 3, 0. All right, so we're looking at that one. All right, and now we need to find slopes. So first one, they have it broken down for us, is A to B. That's up 1, 2 over 1, 2, 3, 4. So that's 2 over 4, which we reduce to 1/2. All right, its opposite side is C to D, so I'm going to jump down here and do C to D next. These are my opposite ones. All right, C to D would be up 1 over 1, 2, sorry, and then over 4, which is the same as 1 over, it doesn't go there. Up 2 over 4, which is the same as 1 over 2. All right, D to A, well, I'm going down 1, 2 over 1, so D to A is negative 2 over 1. C to B, 1 down 1, 2 over 1, so negative 2 over 1. All right, from this we can tell a couple things. All right, our opposite sides are the same, so we know it's a parallelogram for sure. All right, but now as we look at our opposite sides, 1 over 2 and negative 2 over 1, those are perpendicular, positive and negative, reciprocal fractions. So it's no longer a parallelogram, because now it's more specifically a rectangle. All right, now the reason we still have to find the distance, all right, this one has you do it for all the sides. I'm only going to do it for opposite ones, because as I said, since it's a parallelogram and rectangle, we know AB and CD are the same, and we know BC and DA are the same, so I'm only need to pick 2 of them. All right, but what we're looking for here is if those sides are the same, it's a square. If they're not the same, it's a rectangle. So here we go. We're going to do A and B first. So this would be the square root 1, not comma, 1 minus negative 3 squared plus 2 minus 0 squared. All right, 2 minus 0 is 4. Or 2 minus 0 is 2, squared is 4. 1 minus negative 3 is 4. Squared is 16. That equals the square root of 20. So what that means is CD is also going to be the square root of 20. For B to C, All right, we got the square root of 0 minus 1 squared plus 3 minus 2 squared. I think, right? Yep, up 0, 4. So that should be 4 minus 2 squared. My bad. Right, 4 minus 2 is 2. Squared is 4. 0 minus 1 is negative 1. Squared is 1. 1 plus 4 is the square root of 5. dA would be the same thing. Those are not equal, so we know most specifically it's a rectangle. All right, so if those were the same, it would have been a square. All right, if these were to be the same, but these were not perpendicular up here, it would be a rhombus. All right, if these weren't perpendicular and these weren't the same, it would just be a parallelogram. If these weren't the same, these weren't perpendicular, and the opposite sides, so like A, B, and C, D, weren't parallel, it wouldn't even be a parallelogram. We would just call it a quadrilateral. All right, guys, if you have any questions, please let me know. I'll have this uploaded shortly. Have a great day.